Hello there. In this class we are going to be introducing the Boolean operators. In the last class we gave them a little bit of introduction, but here we are going to properly discuss what Boolean operators are and how do we use them in our Boolean algebra. Now, and there are three Boolean operators in Boolean algebra. One is called AND operator, the other one is called OR operator, and the other one is called NOT operator. Now these three operators can be represented as dot. For the AND operator we can use this dot sign, or sometimes we just leave a small space between the variables to represent this one. For the OR operator we use the plus sign, and for the NOT operator we use this exclamation sign, or sometimes we use this complement sign, or sometimes we write a line over that variable to identify it as a NOT operator. Now what are these operators? How do they operate actually? Now in the background, instead of these operators we have some gates. Now if you remember, if you have studied electronics, you will be familiar with these gates. These are gates with multiple inputs. This is the AND gate, this is the this is how an OR gate looks like. It also can have multiple inputs, and this is what an NOT gate looks like. It has only one input and one output. So this AND operator, OR operator, NOT operator, these works on the basis of these logic gates. So how does the AND gate works? For the AND gate we use this operator in Boolean algebra, and when we are designing the logic design we will use these gates instead of these operators and dots. So when will it return a true value? Now as we know that we are dealing with binary variables, which means we will have only binary operators. The inputs will be either 0 or 1. Just like that the output will also be either 0 or 1. So when the output will be 0 and when will the output be 1? So to see that in the case of AND operator, the AND operator is going to be true when it is going to be true when all inputs are true. When our inputs are 1 is the alternative are true. It means that if this AND gate gets 1 in all the inputs, it will return 1. Otherwise in every other case it will get 0. It will return us a 0 value. Even there is a single 0 in this inputs, it will give us a 0 here. So it means that the AND gate will the AND operator will return a 1 value only if all the inputs are going to be 1s. Then it is going to give us a true value, which means it is going to give us a 1 value. So what about the OR operator? How does this one works? It is true when at least one input or one variable's value, whatever you can say, one input is 1. At least one input should be 1 in this case, and it will return 1 in that case. If it has all 0 inputs but only one input is 1, in that case also it will return a 1. Now these inputs in Boolean algebra are represented by variables, the variables that we discussed in the last class, in the previous class. Apart from that, so this is how it works. The the OR gate is going to be 1 when at least one input or one variable's value is 1. It will return us a true value. So what about this NOT operator? Simply NOT operator is an inverter. How does it works? If we give this one a 0 input, it will convert it into 1, and if we will give it a 1 input, it will convert it as 0 to 0. So it is represented by this one. So let's say if the x value of x, which is a binary variable, its value is 1, and if I do this, it means that its value is now 0 because we have inverted it. So these are the three operators. Now let's see how their truth tables can be constructed and how does it works. So to create a truth table for variables, first of all we would see that how many variables do we have in our expression. Let's say in my case this is my expression, or as I told you, the AND operator can either be represented by this dot, or we can leave a small space between them, just like we do in the multiply. Doesn't matter if we do this one or this one, both are same. So let's see, we have only two variables here. This is our final expression. Now this has only two variables. If there are only two variables, it means that you will have two zeros here, and then you will have two ones here. You will first insert 2 0 in the first column, and then you will insert 2 1s. After that you will go by dividing it by 2. It means that if there is 2, it means that 2 by 2 is going to be 1. So if I divide it, it will be 1. So I will insert 0 here, and then I'll insert word, then I'll insert 0, then I'll insert 1, and so this is how you go away. You go like forward. If you have multiple variables, if you have 3 variables, you are going to start at you are going to be starting at 8. Why? Because 2 power 3 is going to be 8. It means that it is going to have 8 rows when you have 3 variables. So this is how it is built. Now, as we saw in the case of AND operator, that it is only 1 when the all inputs are going to be 1, or we can say that when the all variables are going to give us 1, the AND input in AND operation will be 1. So in this case, if we say here, at least here both zeros, both are zeros, no, both inputs, it means that it's going to be 0. Here only 1 is 0, but we need all of them to be 1. Sorry, here only 1 is 1, a single one of them is 1, but we need every input to be 1. So we will give it 0 to, again here is the same case. But if we see here, all the inputs or all the variable values are 1, it means that it is going to return us a 1. So this is how AND operator works. In the case of OR operator, what will we do? We said that at least one true will do the task for us. So here there is no 1, so it means there is going to be 0. And we said that at least 1 will do. So here there is 1 1, so I'm going to write here 1, this is going to be 1, there are 2 1s, it means that it is going to be 1. So this is how the OR operator works. The mechanism to create the truth table is going to be same. You need to use this formula there too. So apart from that, then we have the NOT operator. How does the NOT operator works? As I told you, it just inverts it. If we have a variable x, there is going to be only 2 rows for that in the truth table. Why? Because I am doing 2 power 1, because there is only one variable with me. So 2 power 1 is going to be only 2, so it means that I am going to have 2 variables here. So one is 0 and the other one is 1. So 0 is going to be inverted into 1 and 1 is going to be inverted into 0. If we have x, its value is 0. If we will take the complement of it, it will give us 1. And if we have x whose value is 1, and if we take the complement of it, it will give us 0. So this is how the 3 operators work. So this is how you create a truth table. Again, I'm going to tell you, if you have number of number of variables is going to be in the power of 2, and by this formula you can find out how many rows you should insert in your truth table. Let's say I have got 3 variables, I'll do the same. Number of variables is going to be 3, so I'll get 8. So if I have 8 rows, it means that I have 8 rows. But how do I distribute zeros and 1? I'll keep dividing it by 2. I'll divide it by 2, it will become 4. So it means that I'll insert 4 zeros and then I'll insert 4 ones. I'll keep going on. I'll divide it by 2 again. I will get 2. It means that I'm going to insert 2 zeros and 2 ones, and then 2 zeros and then 2 ones. Again, going further, it will return us 1. So I'm going to give 1 0, 1 1, 0 1, 0 1, 0 1. So you will keep going on until you get 1 here. Now your truth table is completed. You will name this one as x, you will name this one as y, and you will name this one as z. Now you can write any expression here and you can find out the possible combinations for it. So this is how we create truth tables, and this is how you find out every possible combination of multiple variables that you have. So these are truth tables. In the succeeding class we are going to be discussing, there are some laws or some postulates of Boolean algebra which we call, some of them are identity law, commutative law, distributive law, and complement law. There are 2 more laws, but I don't find them that much important. Those are mentioned in the book, but I will mention them in the next class too. So that's it for today's class. I'll see you guys in the next class.